Hello, and welcome. Today I will be explaining the code used to collect DHT data and display it on a web server by using a ESP32 dev kit. Hashtag include Wi-Fi.h. Hashtag include ESP async web server.h. Hashtag include Adafruit_sensor.h. Hashtag include DHT.h. These lines include the necessary libraries for the project. Wi-Fi.h provides functionality for connecting to Wi-Fi networks on the ESP32. ESP async web server.h is used to create an asynchronous web server on the ESP32, allowing for non-blocking handling of multiple client requests. And are libraries for working with the DHT, digital humidity and temperature, sensor. Const char *SSID equals replace _with _your _SSID. Const char *password equals replace _with _your password. These lines define constants for your Wi-Fi network credentials. Const char *SSID replace _with _your SSID with your network's SSID name. Const char *password replace _with _your password with your network's password. Hashtag define DITPIN 27 / digital pin connected to the DHT sensor. This line defines a constant named DITPIN with a value of 27, which indicates the digital pin on the ESP32 where the DHT sensor is connected. You should adjust this pin number based on your actual wiring. / uncomment the type of sensor in use. / hashtag define DHT-TYPE DHT11 / DHT11. Hashtag define DHT-TYPE DHT22 / DHT22 AM2302. / hashtag define DHT-TYPE DHT21 / DHT21 AM2301. These lines are used to specify the type of DHT sensor in use. Depending on your sensor, uncomment one of these lines by removing the / comment markers. Hashtag define DHT-TYPE DHT11 for DHT11 sensor. Hashtag define DHT-TYPE DHT22 for DHT22 AM2302 sensor. Hashtag define DHT-TYPE DHT21 for DHT21 AM2301 sensor. DHT DITPIN DHT-TYPE. This line initializes a DHT object named DHT using the pin number specified in DITPIN and the sensor type specified in DHT-TYPE. Async web server 80. This line creates an instance of the async web server class named server that will run on port 80. Port 80 is the default HTTP port. String read DHT temperature. // temperature reading and error handling. This function, read DHT temperature, is responsible for reading the temperature from the DHT sensor. The DHT sensor can take up to 2 seconds for a reading to stabilize. It reads the temperature in Celsius by default but can read in Fahrenheit if the true argument is passed to read temperature. It checks if the reading is valid using isNone, and provides an error message if it fails. It returns the temperature as a string. String read DHT humidity. // humidity reading and error handling. This function, read DHT humidity, is similar to read DHT temperature, but reads the humidity from the DHT sensor and returns it as a string. Const char index _HTML, progmem equals our raw literal. / HTML code for the web page with placeholders for sensor values. Raw literal. This is a constant character array, index _HTML, that stores the HTML code for the web page that will be displayed. The HTML page contains placeholders like %temperature %and %humidity %, which will be replaced with actual sensor data. String processor, const string and var. If var == temperature, return read DHT temperature. Else if var == humidity, return read DHT humidity. Return string. The processor function is used to replace placeholders in the HTML page with actual sensor data when serving the web page. Void setup. / serial port for debugging purposes. Serial.begin 115,200. DHT.begin / connect to Wi-Fi. Wi-Fi.begin, SSID, password. While, Wi-Fi.status, equals WL_connected. Delay, 1000. Serial.println, connecting to Wi-Fi. / print ESP32 local IP address. Serial.println, Wi-Fi.local IP. / root for root/web page. Server.on, / http_get, async web server request *request. Request.send_p, 200, text/html, index_html, processor. Server.on, /temperature, http_get, async web server request *request. Request.send_p, 200, text/plain, read DHT temperature.c_str. Server.on, /humidity, http_get, async web server request *request. Request.send_p, 200, text/plain, read DHT humidity.c_str. / start server. Server.begin. In the setup function, serial.begin 115,200 initializes the serial communication at a baud rate of 115,200 for debugging purposes. This allows you to view messages and data on the serial monitor. DHT.begin initializes the DHT sensor. Wi-Fi.begin, SSID, password, initiates a connection to the Wi-Fi network using the provided SSID and password. The ESP32 will attempt to connect. The while loop, while, Wi-Fi.status, equals WL_connected, keeps running until a successful Wi-Fi connection is established. During this time, it prints, connecting to Wi-Fi, to the serial monitor. Serial.println, Wi-Fi.local IP, prints the ESP32's local IP address to the serial monitor once it's successfully connected to the Wi-Fi network. The following code sets up routes for handling HTTP requests. Server.on, / http_get, this line sets up a route for the root page, / for HTTP GET requests. When a client requests the root page, it will send the HTML page with sensor data and placeholders replaced by the processor function. Server.on, / temperature, http_get, this line sets up a route for the / temperature path for HTTP GET requests. When a client requests this path, it will send the temperature as plain text. Server.on, / humidity, http_get, this line sets up a route for the / humidity path for HTTP GET requests. When a client requests this path, it will send the humidity as plain text. Server.begin starts the web server. Void loop. The loop function is intentionally left empty in this code. This is because the code is event-driven, responding to incoming HTTP requests and sensor readings, and doesn't require continuous operation within the loop. The ESP32 waits for incoming requests and handles them accordingly. In summary, this code sets up an ESP32-based web server, initializes a DHT sensor, connects to a Wi-Fi network, and serves a web page displaying temperature and humidity data. The code is primarily event-driven, so it waits for HTTP requests and sensor readings without requiring continuous operation in the loop. Thanks for watching.